And it's recording. All right, so 6A and B looks like two exercises, but again, I don't need you to focus on doing all questions. I just need you to know how to do the skills. The three skills that you need overall for ratios is that you need to know how to read a ratio and you need to know how to simplify a ratio. Most students can do this first one, even without me teaching. You generally know how to do it just from fractions. It's the next one that I want to make sure that you guys practice. So let's do the first one just for those who aren't familiar with ratios. Again, ratios, thank you. Ratios is different to fractions in the sense that we do comparisons by multiple quantities. So for example, I could compare between blue marbles to red marbles to yellow marbles to green marbles, right? So I can compare how many marbles of a proportion. So I could say there's one blue marble, two reds, three yellow, and then say two green. And in total there, that's 8 marbles, right? Fractions, you can't do that in one go like that. So I can't do it in a comparison. What I'd have to do is I'd say there's 1 out of 8 balls is blue. So 1 out of 8 is blue, 2 out of 8 is red, 3 out of 8 is yellow, and then 2 out of 8 is green. But the essence of it is very similar. That's why it feels similar, and then at the same time it feels different. Okay, so ratios is nice for comparisons of quantities, but they have to be the same quantities. And you notice that they always use the numbers, no units. It's because we're just comparing, assuming the units are the same. Okay, so for example, if I did 8 cents to $2, which one's bigger? Second one. So you don't look at the value, you look at the units. But you never write your ratios as 8 cents to $2. You would actually write it as 8 for 8 cents. But to actually show the comparison, it should be 200 cents. So this is called an 8 to 200 ratio. Does that make sense? Okay, so with ratios, we assume that the units are the same, so that way you can compare. Otherwise, it becomes 8-2, which makes it look like this one's bigger, which we know is not true. Okay? So let's start off with the first skill. The first skill is to simplify. So let's look at 820. That's a ratio. So I've got 8 parts. That is whatever it is. So let's say 8 parts water, and then this is cordial. Yeah, that's a very sweet drink. I know. Should be the other way around. But if I want to reduce this, I need to find a common factor. What's a common factor of 8 and 20? Can I please have Elijah? What number fits in 8 and 20? 2. We can have 2. There is a bigger number. Can anyone think of a bigger one? Amira? 4. We got 4, and I think that is the biggest one. So either way, whether you went with 2 or 4, it still works. You just have to simplify it to the simplest form. So if you did it with 2, you would end up with 4 to 10, which means that you can still simplify further because you didn't choose the highest common factor. So then you can divide it by 2 again, and you get 2 to 5. But if you did it through the highest common factor, 8 to 20, if you divided this by 4, like Amira said, then 8 divided by 4 gives you 2, and then 20 divided by 4 gives you 5. So it's a 2 to 5 ratio. What we're saying when we say 2 to 5 ratio is if you imagine there was one full block, I'm cutting it into 2 parts for this section, and they're equal parts, and there's 5 left over. 1, 2, 3, 4, and 5. These are different. So in total, how many parts do I have? I've got 2 plus 5, which is 7 parts in total to make up this whole. Okay, that's the key difference. So when you say 2 to 5, you have to understand this means 2 out of 7, and that means 5 out of 7, because there's a total of 7 parts. Okay, and that's one of the techniques that you will use to solve the next problem. Okay, but just for the first skill, you need to know how to simplify 2 to 5 ratio. Can I get a show of hands who understood example A, finding the common factor to simplify? Good. So most of you should be able to do that in terms of practice. So that's 6A. Exercise 6A, that's what you're doing. Then you move into, say, the second bit, B. Got to be careful of units. The difference is one says 3 meters and one says 50 centimeters. It would be wrong to write 3 to 50 as a ratio. Why? Will?
3 meters, 300 centimeters.
Very good, because the units are different. So it's not comparable. You can't say it's 3 to 50 and it makes 50 look larger. The reality is that in terms of meters into centimeters, that's meant to be 300 centimeters. So technically the real ratio should be 300 to 50. But the answer we leave is never in the biggest form. We always try to simplify it. Will?
6 to 1.
6 to 1. What is the common factor though? 50. Very good. So again, it's whether you can find the highest common factor. Highest common factor in this case is 50. But if you didn't know, you could have tried 10. You could have done divide by 10 and you would have got 30 to 5 and then divide it by 5. And you would have got 6 to 1 like Will. So like I said, it doesn't have to be the highest common factor, but that is the quickest way to get to your final answer. So yes, the answer is if you divide both sides by 50, you do get 6 to 1. Don't write the units. Okay, ratios don't have units. Cool? That is what you're practicing in 6A. So if you find that your skills in simplifying fractions and simplifying ratios is not strong, that's what you practice. But if you do feel confident with that, then I don't want you to spend a lot of time there. What I do want you to spend more time on is this skill that I normally see year 8s not be able to do on my test. So when I create a test, I chuck in maybe mixed fractions, I give you improper fractions, and then that's usually left blank or they do it wrong. So if you don't know how to do this one, I want to teach you. Ratios, we don't write it with fractions or decimals. It's always whole numbers. So how do you get a fraction into a whole number? There are 2 methods. It depends on how strong your multiplication skills are. The easiest way is to find LCM. But if you're not good at finding LCM, then this is my next technique for you. Okay, this is for the general maths if you don't know your times tables well. If you don't know your times tables well, this is the easiest way to do it, but it is a bit longer. This is how you do it. See that divide 5? That fraction? That's what most students hate. It's the denominator. They don't like fractions. So get rid of it. Now, when we read it, this sign here means divide. And then you're dividing by 5. But what's the opposite of dividing 5? Times. So if you do the opposites, it will cancel out. It's almost like saying add 3, and then the opposite of adding 3 is subtract 3. So if I got you to add 3 and then subtract 3, well, you haven't really done anything because it cancels out. Same thing with this. If you said 3 divide 5, so if you type 3 divide 5, if you want to remove that division, times by 5, and nothing actually happens. Okay, I'll show you. If you didn't understand that idea, I'll show you on a calculator. I know. Sometimes students don't realize this, but the opposite operations cancel things out. So 3, I start off with 3. If I said times 5, I get 15. But then if I divide 5, which is the opposite of that, I get back to 3. It's always undoing itself. So it doesn't matter what you do. I could do 3 times 1,000, and then I say opposite of that is divide 1,000, and I still get back to 3. So the concept here is if these two are opposites, they essentially undo each other. So that means in these fractions, you don't have to be worried about these fractions. If you don't like them, get rid of them. See, that's a divide 5. Then the opposite of that is times 5. These two will remove each other. They're undoing each other, and so you end up with 3. But whatever you do to one side, you have to do to the other because you're keeping the proportions the same. If you times one side by 5, you now made it 5 times larger than what it was. You have to make sure this is also 5 times larger than what it was. So here we go. Times this side by 5 as well. 1/6 times 5. Now remember, 5 is a fraction. How do you write that again? 5 over 1. So that's the fraction for a 5, a whole number. And when you're multiplying fractions, it's top with? Top with top, bottom with bottom. So 1 with 5, 6 with 1. So now you get 5 over 6. So that still looks scary. But still, like I said before, if you don't like the fraction, get rid of it. How do you get rid of that fraction? What do you do? Times by 6. Because that says divide 6. Instead of dividing 6, do the opposite of that. Times 6 on this side, times 6 on the other side. Together you get 18, 2, and the 6 cancels out. You get 18 to 5. Okay, and there's no common factors in 18 and 5, so that is as small as you get. So 18 to 5 is actually equivalent to 3/5 to 1/6. If you didn't like that method because it was a bit longer, it is the easiest way to understand it. The other way, the most efficient way, is to find LCM. So LCMs, you got, again, 3 out of 5 and 1 out of 6. So you look at the bottom numbers, 5 and 6. What's the lowest common multiple of 5 and 6? Not factor. Multiples. So if you go 5, 10, 15, 20, 25, 30, 35, 40, and you went with 6, 30. Okay, so 30. This is what I mean. So not all students are very strong at knowing the difference between LCM and HCF. That's why they don't like this technique or they forget how to use it. But if you do remember it, then it's easier because once you know it's 30, all you have to do, times both sides by 30, and you'll get your answer in one go. So here we go. When you multiply them, notice this is 30 over 1, and this is also 30 over 1. But you see 30 and 5, they have a common factor. What's a common factor? 5, good. 5 goes to 5 once, so it cancels out. And then 5 goes into 30. How many times? 6. So this becomes 6, this becomes 1. 6 times 3 is 18. And same thing on this side. Common factor is 6. So 6 goes to 6 again once, so it cancels out. And 6 goes into 30 5 times. And then 1 times 5 gives you 5. So you get the answer in one go, but you have to understand LCM. Again, depends on your multiplication skills. So if your multiplication skills aren't strong, then what I'm showing here will always work because you just get rid of the denominators. Yeah? All right, so that is 6A. So in 6A, you will get a variety of these 3 problems. A, whole number ones. B, different unit ones. And then C, fraction ones. So you can get mixed fraction, you can get improper fraction. You just need to know how to do each of those skills.
How did you get the LCM is 30?
Because we looked at the denominators. So you had a 5 and you had 6. And then we look at the multiples of 5 and 6. So we go 5, 10, 15, 20, 25, 30, 35 onwards. Then we look at 6 times table. 6, 12, 18, 24, 30, 36, 42, 48. What we can see is that the lowest common, so when are they both in common? It's when that occurs. And so that's called your lowest common multiple. And it just means that for both ends, if I times it by 30, eventually it will fit nicely. So how many 5s will fit nicely in 30? 6 times. And how many times will 6 fit nicely in 30? It will fit 5 times. That's why you look for LCM. So you're converting a fraction into a whole number, essentially. That's why you do that. All right, team. Hands up if you understood the mission of 6A. Okay, so 6A is simplifying. You don't have to do all the questions. I'm just looking for, can you do these 3 different skills? Okay? If you got that, just train the ones that you need to improve better. If you already got them, move on. 6B, this is the next question. 6B, there's a lot of ways to do this one, and I know a lot of students do it differently, but I found this is one of the most simplest way to understand it. So here we go. Let's look at example 2, and that's it for today's lesson, yeah? Adrian contributed, say, $2, and Bethany contributed $3. So A and B. To buy a ticket, there was $5. So this is $5 for a ticket. And it just so happens that this ticket, they won a lottery prize of $300. Okay? What's the problem if I took the $300 that they won and split it into 2, which each of them get $150? What's wrong with that? Why doesn't that work?
Adrian didn't contribute much.
That's right. Technically, it's not a fair 150-150 because technically Bethany put in a bit more. And so she technically should win a bit more of the money rather than an even split. So the question is, how much should Adrian get and how much should Bethany get? Now the technique, I'm just going to pause there. Technique-wise, there's many ways to do this. You can do it fraction way, or you can do the most logical way, which is what I see students do. This is what most students generally do logically. And it works when it works. It works when it's a whole number. Doesn't work too well if you don't know your fraction skills. Okay, so I'll show you the whole number way. So the total prize, how much was the total prize again? $300. So this block represents $300. We know that Adrian contributed $2, whilst Bethany contributed $3. So it's a total of 5 parts. Can you see that? If I split this block into 5 equal parts, Adrian contributed 2, so he gets 2 of them, and Bethany contributed 3 of them. So in total, that's 5 parts, and out of those 5 parts, it makes up 300. So if you can figure out how much each part is worth, then you can figure out how much Adrian should get and how much Bethany should get. So the logic is 300 divided by the number of parts. Now I've got 5 parts, so 300 divided by 5 gives you 60. So what that means is, so I'm going to write here, 300 divided by 5 parts means that each part is $60. So that means this is 60, this is 60, this is 60, this is 60, this is 60. So you can actually see there, how much would Adrian get? If Adrian gets 2 parts and each one is $60, isn't it just 2 times 60? Or another way of looking at it is a 2 to 3 ratio times 60 to get both parts, and then to get 3 parts here times 60. So you should get 120 to 180. If you add these two together, they should add up to $300, but I can now tell that Adrian gets 120 and Bethany should get 180, not 150, 150. This is probably what I've seen most students do in a logical sense. They find the number of parts and they divide the total prize by the number of parts to figure out how much each part is worth. Okay, question?
What's wrong with Adrian just paying Bethany $1 and then they split it equally?
Paying. Oh, because that's after they won. But if they didn't win, I guess Bethany could earn so much more. Bethany would have how much more than Adrian right now? So she's got 130. She's got $60 more. Why would she want to take that 50 cents, so take that extra dollar, and then give Adrian $60 extra?
Because it was originally Adrian's money.
Originally Adrian's money. I think it's a hard negotiation, but if you're really nice like you are, Yuri, maybe Bethany would do it for you. All right, second approach. Thank you. All right, so if that approach gelled with you, that does work. What's the caveat? Listening. What's the caveat to this method? Is that you're relying on the one fact that 300 divided by 5 actually works. So had I changed the scenario, had I said 2 to 7, to 7, so $2 versus $7, that's a total of 9 parts. So then if you tried to do 300 divided by 9, then students get stumped here. Okay, and there's nothing wrong with that. The technique is right. There's nothing wrong with the technique. It's just the students get stumped when it's not a whole number. Students love whole numbers. I'm telling you to get used to fractions. Yeah? If you did get this question and you like method number 1, keep it as a fraction. It will be 300 over 9. It's okay. There's nothing wrong with 300 over 9. It doesn't have to be a whole number. And then what you do here, instead of timesing by 60, it'll be timesing by 300 over 9, times this by 300 over 9. That's probably what the problem is with most students. So if I change this problem to see if you understood how to do it, I find that students don't know how to do it if I gave them something that didn't give them a whole number. Because sometimes when you divide it, it could be cents. It could be 1.5 times or 1.2 times. It doesn't have to be a nice $60 each part. Okay, so these are the questions that are easy to start off with the 6B. And the other questions will then force you to work with fractions. Okay, so that's the only caveat with the first method. So if you like it, good. It just means when you get these problems, you have to be okay with working in fraction form in this step here. Okay? The other way, which means you get right into fractions. Here's the other way. Method number 2. Method number 2, we already know Adrian put in $2. So 2 parts is Adrian. Bethany put in 3 parts, which is 3. So that means in total is a fraction. Adrian contributed to, out of the 5 pieces in total, contributed 2/5 of the prize. And then same thing with Bethany. Bethany contributed 3/5 of the prize. So if you wanted to actually work it out, this is where you jump right into fractions. $300, Adrian should get 2/5 of 300. Now using what you've learned from percentages, 2/5 is a fraction already, so you don't have to write anything there. 2/5. What does of mean again? Times. So it's just 2/5 times 300 over 1, because 300 is a whole number turning into a fraction is 300 over 1. And this is your job to simplify. So from here, which two numbers can you see that we can simplify straight away? 305. And that's where you can simplify it and say, yep, that's 1. And then that's, what's that? 60. So then it becomes 2 times 60, 2 over 1 times 60 over 1, and you get the same answer as before. It's 120. So this is directly going to the fraction form. And it means that if you practice this skill and you're better at this, even if I changed it to 2 to 7 before, even if I did this one, you would still know that Adrian gets 2 out of 9 parts and Bethany gets 7 out of 9 parts, and your techniques don't change. It's the same technique over and over. You still do 2/9 of 300, and you still do 2/9 times 300 over 1, and then simplify. Okay, so the benefit of practicing this is that your fraction skills get really strong. Then you're not as afraid to apply fraction skills. What's the problem with doing this one? This skill is nice, it's intuitive, it makes sense, but when the numbers don't work out nicely, students give up and it stops. And that's why I'm saying that the missing link there is fractions. The better you are with multiplications and simplifying, the stronger you can either go both directions. Okay? So that's it for today's lesson. That's 6B. That is one of the key skills that I do want you to know how to do. It's going to be on your test for sure. I'm going to do versions where there are whole numbers. I'm going to do ones where there are going to be decimal versions. And I'm going to do ones where it's not just 2 ratios. It could be Bethany, Adrian, and David. Yeah, I've already got them done. So there's ones with 3 of them. Maybe I could even put 4 if I wanted to. The point is, can you work with the numbers even if I increase the difficulty? You will get a revision. You will get a revision. It's kind of like what they did in class. Yeah, you get some revision. All right, team. I'm going to pause there, and that's it for today's lesson. Tomorrow, you get the first half to work on any of the exercises that you need to, and then the second half, I finish off with the theory in 6E, and then Friday is your session. It's a full session because I'm not here. Someone will be substituting. You'll do your work on Friday, and then next week is revision, and then your mastery before we look at the end of the term. Okay? I won't even know until when I'm gone. Yeah, I'll have an idea of when I interview, but at the end of the day, I'm not the one that makes the call on who gets to hire. Yeah. You're gonna